Hi, welcome to the channel. I'm Lauro Miller and I make videos about programming. In today's video, we're going to talk about numbers in JavaScript. We'll also cover arithmetic operators and some tricky things to keep in mind when working with floating points. If you don't know yet, because maybe you didn't watch some of my previous videos, each video of this introduction to JavaScript series has an online interactive exercise session that you can use to practice everything we discuss here directly from your browser. The link for the online exercise is going to be in the description of this video, so make sure to check it out. Let's switch Notion and let's get started. Numbers. As you may expect, there are also some tricky things we need to keep in mind when we are working with numbers in JavaScript. Here is a small overview of what we will cover in this video. We start with an overview of the topic and then how to convert other types to numbers. We discussed then arithmetic operators, NaN errors, which means not a number, infinity errors, floating point precision. This is especially tricky if we are working with a lot of numbers in the application, let's say averages or revenues, and we have floating point numbers and we perform some operations with these floating point numbers, then we need to keep this in mind. And then we'll also talk a little bit about some methods to convert precision, so to convert floating point numbers to integers. Let's create a new file here. We're just going to call this overview.js. And remember that we discussed that in JavaScript, the underlying primitive that is used for both integers and floating points is the same. So if I were to console log 1 strictly equal to 1.0, this is fine for JavaScript. Okay, if I were to come here and say node overview.js, this is going to output true, and that's because the underlying primitive is the same. Now if I were to change this to 1 strictly equal to 1n, this is going to be different because here this number, this 1n here, is a big int, is not a number. So I will save this, and if I come back to the console and I run this again, I get a false, right? So you can really think in most cases of an integer as being its floating point equivalent, but without the decimal part. I mean, of course, there's a big generalization, but you can think of it this way, at least. Maybe in some cases it's not going to be applicable. Of course, some of the conversion methods between floating points or between floating numbers or actually you can say floats, let's call it like this. I mean, in JavaScript, so in Java you have a float type, you have an int type, but in JavaScript you don't really have this, you just work with numbers. But here, maybe just for the sake of brevity, let's call whenever we have a dot here and a decimal part, we'll call this a float or a floating point number. And converting this, rounding this to integers can be done in several ways. We'll discuss this more towards the end of the video. So another interesting thing here is that we can, of course, write numbers in JavaScript that are not in the decimal base. We can also use, for example, binary base with 0b, right? So 0b11. We can also use the octal base. I think that this is with O, like this, and the hexadecimal base with X. Right, so how do we convert between bases? Well, this really goes beyond the scope of this video, but just if you are curious, this is going to output 3 in the console because it's a binary, a number in a binary base. And how do we convert? Well, very quickly, we take each number from the right to the left, and then we start adding it or multiplying it by the base to the power of starting counting at 0. And then, so maybe it's easier if I just do the example. We're going to say, okay, this is 1, so I'm going to take 1 times 2 to the power of 0 plus, and then the second one here is going to be 1 times 2 to the power of 1, right? So you see that I am increasing the exponent as I move towards the left, and the base is always the base that we are writing the number. So if it's a binary number, this base is going to be 2. If it's a octal or a base number in the base 8, this is going to be 8. If it's a number at the base 10, it's going to be 10. And if it's the number at the base 16, this is going to be 16. But the mechanics are always the same. We start counting from the right. We start with the exponent 0, and then every time we move to the left, we add 1 to the exponent, right? So this prints 3. Now, if we were to console.log, let's say 0b10011, for example, let's try to do the calculations before. We'll start in the right here. So with the rightmost one, we're going to be 1 times 2 to the power of 0 plus, then the second one is going to be 1 times 2 to the power of 1, right? Plus then we have 0 times 2 to the power of 2 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 4, right? So we have here 0, 0, 1, 2, 3, 4 seems correct. Now we have here for 1 times 2 to the power of 0, I'll just add another line here at the bottom so that we can follow it better. That's 1. Then we have 1 times 2 to the power of 1, that's 2. Then 0, and then 0, and then 1 times 2 to the power of 4, that is 16, right? So this should add up to 19. Let's see if that's correct. Once we console log this whole thing, it outputs 19, right? So this is how we would convert from different bases. If you had a base 8 here, we can give it a try. Let's see. I mean, I never did that, so I apologize if I make a mistake in advance, but the mechanics should be the same. So this would be 1 times 8 to the power of 0. That is going to be 1 plus 8, right? And if I were to save this and run, that's going to be 9, exactly. Now, one small detail is that I cannot or I should not write a number that goes beyond, that is equal or beyond the base. So if I were to write a number, for example, like this, this is not allowed, right? 7 is the highest number that I can use in base 8, as well as 9 is the highest number I can use in base 10. I cannot write 10, right? 10 is already 1 and 0. And it's always the case that we will have the base minus 1 as the highest digit that we can use. So if we were to calculate something like this, then that would be not 1 times 8 to the power of 1, but 7 times 8 to the power of 1, and that's 56, right? And then if I add, that should be 57. Exactly, perfect. So this is how we can write numbers in other bases other than the decimal base, but I rarely find this in programs. We normally, most of the times, 99.9% of the times, we work with decimals, but I just wanted to show you that it's possible. Actually, add decimals and maybe hexadecimal numbers. This could also be the case, okay? Good, so that's it for the small overview. Let's also talk about converting to numbers, right? So there are a couple of ways that we can convert to numbers, and there is the construct. So we can use number like so, and then let's say console.log, and let's try the 3 different ways, right? So number here, we are going to be 123.45, let's say. We can also call parse float with this 12345, and we can also say, I think it's like this, plus 1, 2, 3, 4, 5, right? And if we were to just make sure that we have numbers here, let's write the type of operator here so that we can output the type of these primitive values, and they are all numbers. Okay, so this is one way that we can actually convert between a string, for example, and a number. I really don't find that useful to convert between booleans. Maybe between booleans and numbers would make sense. So true should output 1 here, exactly, and false is going to output 0, right? Maybe this is also useful, but oh, sorry, maybe I was a little bit too quick here. So you can see here 0, 1, 1, 2, 3, 4, 5, and so on and so on. I'll clear the whole thing. And here, one small gotcha of this parse float, or actually of using parse float for strings, is that if I pass an invalid number, right? So this is an invalid number, for example. And if I call, let's use this same number or invalid number. This should not be a number. Let's use this to the three of them, and we will see that the number one is going to behave differently. Probably I think the plus one will also behave similar to the number. Let's see what is the output. So overview, and exactly. So the first one outputs NaN, the second one outputs just a number, and the third one outputs NaN. And it's interesting that the parse float is really just considering the start of the string, right? So it's simply throwing away the whole stringy letter part here. If I were to add maybe more numbers, I don't know what's going to happen. I mean, yeah, exactly. So it just, whenever it starts finding a string or a non-numerical value, non-numerical sequence, it just throws it away and whatever is after it. Now, the NaN here, you might be wondering what is NaN. NaN is a sort of error. It's not really a typical error that is thrown in the console and breaks the whole thing, but it's just a numerical error, right? NaN stands for not a number. We'll discuss this a little bit later in this video. My recommendation is to use the number, okay? It's the easiest one to identify. It's the easiest one to understand. If you have this plus here, that's you need to be familiar a little bit with JavaScript to understand what this is doing. Sometimes you may get confused, or other people who are reading the code may simply miss this and may not really understand what is going on. Okay, so my recommendation would be to use number. It's perhaps a little bit more verbose than using the plus, but it makes it much clearer to work with code, and whenever we have like large code bases, clarity becomes more important. Awesome, marking the overview and converting to numbers as completed. Let's now discuss arithmetic operators. So arithmetic.js. Okay, and I want to show you I think 6 operators, and let's see here, let's console.log some stuff in the console. Let's say 10 and 3, so 10 plus 3, blah blah blah. Okay, a couple of them. 10 minus 3, 10 times 3, 10 divided by 3, 10 module 3, and 10 to the power of 3, right? These are the arithmetic operators that I mentioned during the operators video. I will put a link. I mean, if you didn't watch it, the card is somewhere here, up here, I think. And you can go there to check the basic rules of operators. I highly recommend that you check that video if you haven't done yet. If you are familiar with JavaScript, if you are familiar with operators, then don't go there. You don't need to go there. But if you're new to JavaScript and some operators seem mysterious to you on how they work, that video focuses on explaining why it is so and the basic rules that JavaScript uses to handle operators. But nonetheless, here we are talking only about arithmetic. Okay, so that's the plus, that's the minus, that's the times, multiplication, and that's division, right? So I expect you to be familiar with this 4 here, at least from school. So this is how they are written in JavaScript. The module is a little bit different. I mean, not different, but basically this simply returns the rest of an integer division, right? So 10 divided by 3 is actually 3, and there is a rest, right? There is a rest of 1, and this rest of 1 is what this module operator returns. Now, you may be thinking, okay, that's not useful at all. But this can actually be quite useful in many cases. Just one example is to identify whether a number is even or odd. You can look at the module of this number when divided by 2. So 10 module 2. And if it is 1, it is an odd number. If it is 0, if it is 0, it is an even number, right? So that would be one application. I mean, there are many more applications in other areas of computer science. I'm just giving you a very, very simple example. But just keep in mind that this is widely used and you are likely to come across when working on other code bases. And this double star here is the exponential. So 10 to the power of 3 is 1,000. Let's save this. Let's run. Oops, that's not the overview anymore. That is the arithmetic. Arithmetic.js, and we get, oh, interesting, right? Okay, we'll talk about this floating point precision a little bit later in this video. That's one of the interesting parts of JavaScript. So 10 plus 3, 13, 10 minus 3, 7, 10 times 3, 30, 10 divided by 3. Here it is a floating point, so that's 3.3333 whatever. Then 10 module 3 is 1, and 10 to the power of 3 is 1000, as we expected. Pretty quick for arithmetic operators. Let's discuss NaN errors, and here we start now talking a little bit more about specifics of numbers in JavaScript. So in the IDE, I'm going to create a new file, and let's say nan.js. The first thing we need to discuss is when do we actually have, so when do we get NaNs? Oops. And it's basically when the mathematical operation is not really possible or is not really defined in the real numbers. Here basically let's try to, for example, take the square root of a negative number, and this we should not be able to do, right? So the square root of, I don't know, -1, or to be slightly less orthodox, -4. If I were to run this here, so node nan.js, I get a nan, right? So another example would be to have the log of a negative number is not defined. So if I were to save this, I also get an nan. But now we start really to get, well, just another way of getting an nan is to multiply a number by, or to multiply a valid number by an nan, right? So if I were to say const sum nan is equal to math.log of -1 here, and then I were to output in the console 3 times sum nan, I will also get nan. So if I save this and I run, I also get nan. Now the tricky thing here is that nan is not equal to itself, okay? And actually, before this, one interesting thing is that although nan is not a number, if we were to print out the type of some nan, we will get a number, right? So JavaScript again to the rescue here. Pretty cool. Now the other cool thing is that we cannot really test if some nan is an nan or is a of nan type, because if I were to write something like this, and then nan here is the JavaScript representation of not a number, this is going to output false, right? nan is really the only type in JavaScript, or the only construct that is not equal to itself. Even if I were to say nan strictly equal to nan and I try to print this, it also gives me false. So one way of identifying, right, maybe it comes the question to your mind, okay, so then how do I know that a number is nan, or that a result is not a number? Well, that is when we use the number.isNaN, right? So number.isNaN, I can then pass here some nan. I can also pass some expression here, or some operation, square root of -4, and these two are going to output true, right? So these two are going to output true in the console. So this is one way that we can identify whether an object or whether a result is nan. Now, one last thing I want to discuss is about arrays, and we can have, for example, const array with nans, and it's going to be an array, and let's say we're going to have 1 nan -10 a and something, whatever, okay? Think that you can add as many terms as you want here. What I want to show you is that the array with nans dot, I think it's the index of, and I can try to find nan here. I think that this doesn't work. Let me see if that's the correct one. Exactly, that's the correct one. You see it returns -1 here. -1 is returned when a certain element is not present in the array. So if I were to say, let's say 11, for example, 11 is not in this array, right? I'll save this, and this should return -1. This is the behavior that is expected. Now, if I were to add 11 here in the 4th position, meaning the 3rd index, because index start at 0, so 0, 1, 2, and then the 3rd index, then the index of operator or the index of method should return 3, right? And exactly it returns 3. Now, if I want to find NaNs in the array like this, then this is not going to work. As I already showed you, it returns -1. But even though the index of doesn't work, we can actually we have other methods that will help us. So let's try, for example, the includes, right? If I were to save this and then run node nan.js, includes actually returns true, which means that the array contains an nan. There are other ways, for example, the find index method. And the find index method, it actually does not receive a value as a parameter. It receives a function. And let's understand what is going on here. So, for example, first let's try to find the number 1. Or let's try to find the number -10 because number 1 is already here. So how does find index work? It's going to iterate over the array, and then in each iteration, EL here, or whatever you want to call it, it can be val as well. This is just the name of the parameter. This is an arrow function, right? Remember we discussed this during the JavaScript syntax overview, and we will come back to this when we talk about specialized functions. But the idea here is that it is receiving a function, and then over each iteration, this value here is going to be populated with an element from the array. So in the first iteration, it's going to be populated with 1. The second one is going to be populated with nan, then with -10, with 11, and then with the string a. And then it's going to perform the comparison, which returns a Boolean value, right? It returns true if the value is equal to -10, otherwise it returns false. And the find index is going to return the first index or the index of the first element that returns true to this condition. Okay, so if I had, for example, 2 -10 here in this array, I save this and then I run the code again, it's going to return the index of the first, index 2, right? Because the element is in the third position, and remember, indexes start at 0. So it's going to return the index of the first element that matches this condition. Now we can use this to find NaNs by simply calling the number.isNaN, and this is going to be with value, right? So now I am able to identify which numbers or which element, what is the first element that is actually an NaN. If I save this here and I run in the code, then, or I run in the console, this is going to output 1, which is the index of the NaN term. Now I know that there are quite a few things here that are maybe a little bit shady for you if you're not familiar with functions in JavaScript. This is the equivalent, the function equivalent, right? So the function equivalent is going to receive a parameter here. It can be value, and it's going to return the number.isNaN with value. If I save this, then I'm going to get 1 and 1, right? So they are exactly the same. The arrow function, as you can see, is a little bit more concise. And by not wrapping this with curly brackets, I am actually returning this value as a result of this function. Okay, if I were to wrap this with curly brackets, then I need to add a return statement here. Okay, I need to add a return statement. Now, we will talk about this, of course, in much more detail later on. I don't want to talk too much about how to iterate over arrays, how to use methods to find indexes, or to check the includes and so on. Discuss this in details here because that's not the goal of this video. The goal of this video is also not to cover the details of functions. We will come back to this when we talk about specialized and ordinary functions. But for the moment, I just want to show you that there are methods for us to identify not a number elements in arrays. Let's mark NaN as completed, and now let's discuss infinity errors. And as expected, infinity errors, they really happen when we have the result of the operations as being too large to, or the result is just too large, it's beyond the upper or below the lower threshold of numbers that JavaScript can handle. For example, console.log, let's say 2 to the power of 124. If I were to run this, I will have, so node infinity.js, I get infinity, right? If I were to decrease here by 1, then I'm going to get the result that is in the scientific notation, which simply means 8 dot whatever is here, And then after the e here, this means times 10 to the power of 307. Okay. If I were to console.log 2 to the power of 1023 plus 1, let's see what this is going to output. It is still valid. And if I were to write plus 2, it is still valid. So as you can see here, there is some threshold. The threshold is somewhere in between 2 to the power of 23 and 2 to the power, sorry, not 2 to the power of 23, but 2 to the power of 1023 and 2 to the power of 1024. Okay, so if I were to write this again, this is going to print infinity. Another example is if I divide things by 0, or if I take the logarithm of 0, so let's say 6 divided by 0, this is also going to be infinity. Or if I take math.log of 0, this is going to be minus infinity, right? If I save this and I write it again, I have infinity, infinity, and minus infinity. Now, just because I can work with numbers until 307 zeros, right? So whatever number times 10 to the power of 307, it doesn't mean that every number can be represented in JavaScript. For example, let's say this one, console.log 2 to the power of 54. Okay, let's try to console.log this, and then we get this number here. And if we were to console.log 2 to the power, so just an interesting number, const interesting is equal to 2 to the power of 54. And then this is already beyond the threshold of safe integers in JavaScript. If I were to console.log interesting plus 2 strictly equal to interesting, this is going to output true. Okay, if I were to save this, this outputs true, and that's very interesting. That's why the name of the variable, right? Very creative. And that's very interesting because this is outside of the range of safe integers. This is due to the way that JavaScript handles numbers. And the range here, in case you were curious, is between minus 2 to the power of 53. And then here, I don't remember if it's minus 2 to the power of 53 plus 1 or minus 2 to the power of 53. But here is minus 2 to the power of 53 and 2 to the power of 53 minus 1. Okay, so that's just for you to be informed about it. And I have quickly checked, and this is also minus 1. Okay, so of course you don't need to know exactly which numbers these two lead to, right? Or what is their decimal form, but just for you to know which are the thresholds. Okay, yeah, what else? Well, the infinity so the comparison with infinity num, right? Let's say 6 divided by 0. The comparison with infinity is actually fine. I can use infinity num strictly equal to infinity, and JavaScript is fine with this. If I save this and I run here in the console, then I'm gonna get true, right? I can also use the math.isFinite, is finite method, and this is going to output true if the number is finite. Otherwise, it's going to output false. If I save this, this whole thing here should output or should print false in the console. And I have an error, of course, because math.isFinite is not a number, and that's not math, that's a number, right? So sorry, small mistake from my side, and then it outputs here false in the console. Okay, that's it for infinity. Actually, let's mark this as completed, and let's go a little bit more into floating point precision. So I'm going to create here a new file, precision.js. And floating point precision is quite interesting in JavaScript. Why? Well, because 0.1 plus 0.2 should be equal to 0.3, right? So let's save this, let's clear the whole console, and let's run node precision.js, and we get false. Oops, what's going on, right? I mean, interesting. If we were to get maybe, I don't know, let's try something else. 1.3 times 9, right? This should have like 9 times 3 is 27, so this should be equal to 11.7. and then I save this and I run, and again I get a false, and that's starting to get quite interesting. So what happens here is that JavaScript cannot represent these numbers in base 2 correctly, so they have some approximation issues. If I were to console their results, let's see what's gonna happen or what's gonna be printed in the console. And as you can see, we have a bunch of zeros after the 3, but in the end here we have this 4, right? And this is exactly the same with the 10 divided by 3 here. If I save this and I run, I also get the 5 here, and in the 1.3 times 9, I get the 1 here at the end. So this can be quite tricky if we are hard coding things in our program. So if we are doing the check is equal to 0.3, right? For example, if I were to actually try to write something like this, less than or equal to 0.3, and as you can see here, there is a 4 in the end. So if I run this, I actually get a false, right? So if the 0.3 was a threshold for an if statement, then this condition, although mathematically it is correct, in the program it would be false. And then we would have a bug, and we wouldn't have a clue where this bug is coming from because the bug is really due to the way the JavaScript handles floating points behind the scenes. So it's important for us to be aware of this issue, and there are ways to round things up in JavaScript so that we can account for precision. Let's have a look at one possible implementation, one possible function that would do this rounding for us. So actually, let me keep this on the screen, and then here we'll have function round to places, and this is kind of not a hack, but it's definitely not how we would like to do things, right? I mean, we would like the language to be able to handle this, but we need to implement these rounding functions ourselves or rely on the methods that are provided by JavaScript to actually round things to a certain number of decimal places. So if I want to round a certain value to a decimal place, then the first thing that I can do, or one possibility, is I can write this as a string, and I'm going to add here value plus, and then remember the scientific notation e plus, and then the number of places, right? So this means that if I pass, for example, 1 and 2 here, so maybe we can do this step by step. I'm gonna write the result here down here, and then we will see if we pass this with 1 and 2 places, then str num is going to be equal to something like, it's going to be a string because we are concatenating a string here. So this value here is going to be coerced to being a string as well as a num places, and this is going to be 1 e plus 2, right? This means simply 100, or 1 times 10 to the power of 2, and this is an intermediary step for us to actually get the rounding that we want. The next step is for us to actually round this number. So we'll say rounded num, and this is going to be a number, or actually math.round. We'll discuss math.round in a bit, but math.round with a number, number of str num, okay? And this is going to round the number up or down depending on the latest digit. And then we actually need to take this rounded number, and then we need to divide, because here we are multiplying by 10 to the power of 2. So now we need to divide by 10 to the power of 2 to return back to its original magnitude, right? So here we can actually return, let's parse the result here, and it's going to be return rounded num plus e minus, and then this means 10 to the power of minus the number of places. Okay, now I know that this may be a bit confusing. I mean, not a bit, it's very confusing, especially if you're new to the language, but let's see what happens once I call round to places 0.1, 0.2 with one number of places, right? So I'm gonna save this. Let's comment these two out just to see the output. The output of the first console log. So I save this, let's clear the whole console, and here we are going to run node precision.js, and then now, yes, finally I get that this is true, right? So once I round 0.1 plus 0.2 to one decimal place, then I get that it is less than or equal to 3. And if I were to compare with strict equality, I will still get true. Now we can also check this with the two console logs here at the bottom. Let's say round 2 places, and 1.3 and 9 to one place. This should be equal to 11.7. And the console log round 2 places, 10 divided by 3. And then here I'm not exactly sure whether JavaScript will be able to handle the 3.333, but let's see. It is. Okay, perfect. So now we have a function that enables us to round correctly. Okay, yeah, I know that this function is perhaps it doesn't make any sense what we are doing here, especially if you're new to JavaScript. I will post a link to the description or in the description of this video that talks exactly about this issue of rounding. It's a discussion in Stack Overflow, and I highly recommend that you go and you check this if you want to know more about rounding floating points or about rounding these tricky numbers, not only these tricky numbers, but any number for that matter in JavaScript to a certain number of decimal places. Okay, the link is in the description. If you want to check it, feel free to do so. Let's mark floating point precision as completed. Here again, I call your attention to this because this can be a very, very dark source of bugs, especially if you are doing those checks with decimal numbers. Okay, make sure to keep that in mind. Not every number is going to be handled nicely by JavaScript, and it may be the case you need to do some additional rounding to get the results you expect. Back at IDE, let's create a new file, last one, that's going to be called converting.js. So there are a few ways we can convert to integers, and the 4 ones that I want to discuss with you today, they all come from the math object or from the math library. I don't know if you would call it a library or an object. I mean, let's not get held back by semantics or by syntax. Let's just, I think, semantics in this case. The four ones that I want to cover here are the math.round, the math.trunc, the math.seal, and the math.floor, right? So let's explore each one in details. First one, math.round, and math.round, what it does is it actually rounds the number to its nearest integer, taking into account the point or the last digit, meaning that if it is 0.5 or more, or if it is 5 or more, it's going to round up. If it's 4.9999999 forever or less, it's going to round down, right? So console.log 1.2, sorry, math.round 1.2, that is going to be 1. If I were to console.log math, so math.round 1.4, that's going to be also 1. And if I were to console.log 1.4999999, that's also going to be 1. And then whenever I reach the threshold of 0.5, this is going to go up, right? This is going to go to 2. And then here, if I have 8, this is also going to be 2. So I will clear the whole thing here, node converting.js, and then you see 1, 1, 1, 2, and 2 as expected, okay? So the rounding really works as we would expect from a rounding operation in mathematics, no big deal. Now the truncation here, what it does is it actually just gets rid of the whole decimal part and it leaves only the integer. So all of this will actually turn into ones once we save this. So I'll just remove the ones that we covered already because otherwise it's going to get a long list of numbers. It's going to get confusing. So I'll save this, and once I run, I get 1, 1, 1, 1, 1, right? No unexpected issues here. If I were to change some of them to 2, then I would get 2, 1, 2, 1, 2, 1. No, 2, 1, 2, 1, 2, right? And yeah, that's how the truncation works. No big surprises here. The seal is actually the equivalent of sealing, right? So a little bit short for sealing, and it means return me the next integer, right? So return me the smallest integer that is greater or equal to the number that I am passing here. So let me, how do I do that? Yeah, like this, CO, okay? This is gonna return 3. So for the first one, it's gonna return 3. For the second one, it's gonna return 2, 3, 2, and 3. I'm gonna save this. I'm gonna run in the console 3, 2, 3, 2, and 3, right? So again, it just looks at the number and then it returns the immediate next integer. The floor, on the other hand, it returns the immediate previous integer. So if I have 2.2, it's gonna return 2. If I have 1.4, it's gonna return 1. If I have 2.49999, it's gonna return 2. And then it's gonna take the integer, so the largest integer that is smaller than or equal to the number we are passing, okay? So math.floor, I just forgot to update here. Floor, there you go. So math.floor of 2.2 is going to be 2, and math.floor of 2 is also going to be 2. Let's save this, and I'm going to remove the ones here at the top, and we're going to run this program, and then we get 2, 2, 1, 2, 1, 2. Okay, no big surprises here for math.floor as well. Just think, okay, I'm gonna get rid of this. I mean, yeah, that would be the truncate one to get rid of the decimal part, but the floor is actually doing pretty much the same. Okay, it's just getting rid of the decimal part and then it's returning the integer. So the smallest or the largest integer that is less than or equal to the value that we have here. Awesome, we can now mark converting to integers as completed. As you saw, there are some tricky things to numbers. They are not directly straightforward. They are not super easy to understand in JavaScript. There are a few things we need to keep in mind. Hopefully this small overview gave you all you need to understand what is going on with numbers in JavaScript. That's it for now. As you can see, there are a few pitfalls when working with floating point numbers in JavaScript, and that's why I decided to make a slightly longer video to cover all these topics. In the next video, we'll start talking about strings. If you don't want to miss it, as always, subscribe to the channel and you will get a notification when the video is out. I'll see you in the next video. Bye bye.